So this means that example 2.4, we're going to just be looking at those same steps. We're going to be thinking about what are unique situations that could happen in the question, and just get some practice graphing different ones. So this is on page 130. Okay. So first of all, we factor completely. And in factoring this one completely, the top is x minus 4, x minus 1. And on the bottom, we have a 1 minus x. So we wrote a note, and we'll rewrite that note, that whenever you have the same factor, but they're sort of flipped, one is x minus 1, one is 1 minus x, you can factor out a negative. So we list our non-permissible values. X can't equal 1, but we notice that this x minus 1 actually simplifies. If it simplifies, we get a new equation, right? Look at the green note. If there's a hole, you graph the simplified equation and adds a hole. So our simplified equation is going to be, I'm going to write it in green because it's the green note. What's left after I cancel out the x minus 1s? I'd be left with an x minus 4 on the top and a minus 1 on the bottom. Okay? Personally, divide that minus 1 through, you're going to get negative x plus 4. And we know this is a hole. Non-permissible value is 1. Do you remember how we find the y-coordinate of our hole? We find the y-coordinate of our hole by plugging it into our new equation. So negative 1 plus 4 would be positive 3. I'll write it in green so you can remember that we got it from our green equation. So originally, you were not allowed to plug in 1 because that would cause you to divide by 0. But after it simplifies, you could plug in 1. We would get the point 1 comma 3. And so what do? Look, the note, if you have a hole in your graph, you graph the simplified equation and add the hole. The simplified equation is just a line. We can now skip all of the steps on the right because we reduced our equation to a line. We just have to graph that line and add the hole. So how do I graph negative x plus 4? Well, negative x plus 4 would have a y-intercept at 0, 4. It has a slope of negative 1, which means you go down 1 over 1 to find a point. Maybe you also want to label your x-intercept at negative 4, 0. And we have to add our hole. Oh, our hole is actually right here at 1, 3. So how do we graph a hole? Well, where 1, 3 is, we add a little circle. We draw our line with that hole in our graph. And this one is done. No oblique asymptotes, no horizontal asymptotes, because once you have a hole and you simplify, then you graph your simplified equation. So even though, and this is a mistake that's often made on this one, even though in the original equation you have a higher degree in your numerator than your denominator, the higher degree in your numerator means there will be no horizontal asymptotes. There might be an oblique asymptote, but not guaranteed that there's an oblique asymptote. So the mistake that's made in many students is when they see the degree higher in the numerator, they think, oh, there has to be an oblique asymptote. But in this situation, when things canceled out, we got a new equation, which was just a straight line. This is supposed to be the easiest one of all the graphing. When you have a hole and things simplify to a straight line, then we can just graph our straight line. But sometimes we feel like we still have to do the steps, but this is no longer a rational graph, it's just a straight line. So, circle question number 3.